Hi there. This practice set is for factoring trinomials, a critical and often tricky set of skills for algebra students. Please like and subscribe if you find this video helpful. It's going to work through several practice problems with the solutions and the explanations. So I hope that you find it helpful. Drop a question or a comment below and check out the other videos on the channel, especially how to factor with algebra tiles. I'll try to make sure that I link that somewhere in the video, probably at the end, so you can see how this skill can be done hands-on, and our comparison of factoring methods. So if you're going to work these problems, but you're going to use a different method, it might be helpful to see how the method you're using is related to the area model. So I'm going to be factoring these with the area model. I think the people doing the floor above me might be taking a break for lunch. I have no idea. But if you hear the banging resume, my apologies. It's not driving anybody crazier than it's driving me. So pause the video to work these problems on your own and then come back to check your work. All right, at least it was quiet for like the pause. All right, so again, I'm going to be using the area model, and if you are jumping into this video and you are not familiar with how the area model works, you do need to go and watch the explanation of the area model, maybe even going back to multiplication with it. Okay, it's a super powerful and versatile model to use, but it's also not something that you can probably jump into with the factoring super easily. So for number one, we are going to set this up, and we always want to look for that greatest common factor first. And I often forget to say anything about it. I look for it very intuitively, and just, you know, I notice it when I notice it, but if there's not one, I often don't think to even say anything about it. But there is no common factor here, and I know that. I can tell that for both of these because the first term only has x's for factors, so x times x. The last term only has numbers for factors, therefore the first and the last terms do not have anything in common, so there's nothing in common for all three. We put the x squared term in the upper left, we put the constant in the lower right, and now it gets a little bit messier. We've got to take the a value, which in this case is 1, multiply it by the c value, and then we have to factor that number, and we have to look for a pair of factors that will add up to that middle term. Now, there's an infinite number of things that add up to 4. So we've got 1 plus 3, but we could also have 2 plus 2. So you could have 2x plus 2x or 5x minus 1x. What we do when we do that a times c is we take that infinite list and we reduce it down to a set of possibilities, only one of which will work. And in this case, 1 and 3 multiply to give us 3. 3 is a prime number, so we only have one set of factors to work with, and that makes it really nice because 1 plus 3 is 4. And you just want to double check, make sure both conditions are met. 1 times 3 is 3. 1 plus 3 is 4. So we'll have a 1x and a 3x. Does not matter where you put those, okay? They can go either way. And then we do GCF factoring in one direction. So the greatest common factor between x squared and 3x is just an x. And the rest of this can be done with multiplication. So x times what gives me x squared, x times what gives me 3x, and then we'll use those numbers or letters to get the others. So this would be x times x, this would be x times 3, and then here you've got x times what would give you 1x. Well, that would be just a 1. And the fourth box can always be used as a check. So 1 times 3 is 3. So you've got the 4 boxes and they should all check. So the factors would be the base, which is x plus 1, times the height, which is x plus 3. Next one. So we've got x squared minus 14x plus 48. Not as thrilled with that one because the numbers are bigger, but all right, we can always get started. That's another great thing about the area model is you can always get started with it. Okay, so x squared in the upper left, 48 in the lower right. Remember your a value is a 1. So we do 1 times 48, which is 48. And now we're looking for two pairs of numbers that add up to that negative 14 because we need this area to be represented to represent that polynomial. And there's an infinite number of numbers that add up to negative 14. So like negative 1 plus negative 13 or negative 2 plus negative 12. And we don't want to start on that. So we use the 48 to give us a list of potential candidates. And what we need are the factors of 48. So we have 1 times 48. We have 2 times 24. We've got 3 times 16. We've got 4 times 12, not a 5, but we do have a 6 because 2 times 3 is 6. So that's 6 times 8, not a 7. And then I get to the 8 and the 8's already up there. So now we got to go through and find, okay, of this list of candidates, which is the one that adds up to negative 14. So you're going to scan through here, and it looks like the 6 and the 8 will add up to 14. And you do want to double check and make sure there's not another one, because there's a couple of fairly, they don't turn up a lot, but they're fairly small numbers, so they do turn up. It's a combination that can, I think it's add to 5 and multiply to 6, where you'll actually have two sets of numbers, and then there's adds to 13 and multiplies to 30, I think is the other one, where you might have more than one potential candidate and you've got to do like a double check on it. But the 6 and the 8 look good. Now they do have to add to negative 14. So we're going to make them both negative there and then double check them before we put them in. So negative 6 times negative 8 gives me positive 48. Negative 6 plus negative 8 gives me negative 14. And in those ones that I was talking about where there's more than one combination, you'll catch it in that step, because what will happen is it'll work for one but not for the other, and you're like, oh, I got to go for the other option there. All right, a little GCF factoring. We'll factor this way. So x squared minus 6x. What's my GCF, my greatest common factor? Well, that would be an x. And then moving from there, x times x will give me x squared. X times negative 6 gives me the negative 6x. X times negative 8 gives me the negative 8x. And negative 8 times negative 6 is positive 48. So my factors are the base and the height. There they are. X minus 6, x minus 8. All right, next one also does not have a GCF for the same reason. I've got only x's in the first term and no x's in the last term. So I know there's no GCF. I believe we do have some with GCFs, but x squared, negative 28. Multiply 1 times negative 28. So negative 28 is the number we're going for. I ignore the negative for the moment just because I don't want to duplicate pairs in my list. And we're looking for a pair of factors that will give us a 3. So 1 times 28, if they're the same sign, so they're both positive or both negative, I could get a 29. And it might be a positive 29 or negative 29. If they are opposite signs, meaning one of them is negative, then I could get a 27, either a positive or negative 27, depending on which one is negative, but I can't get a 3. We've got 2 times 14. So that doesn't work to give me the 7. That I can get a 16 or a 12. 3 does not work. But 4 does. We could have 4 times 7, and I can get a 3 from that. 5 doesn't work, and 6 doesn't work. So I need to get a positive 3. So I can get a positive 3 if the 4 is negative and the 7 is positive. If you want to do that, double check. This is where the negative comes back into play. Negative 4 times positive 7 is negative 28. So I got the negative 28, and negative 4 plus 7 is positive 3. So we'll put in the negative 4x and the 7x. That just lets us know how we're going to break it up. And then we do our GCF factoring. Greatest common factor between x squared and 7x is x. You might also notice that whenever you have an x squared there, that the two sides of that have to be x times x. And so a lot of students will just jump to that. Depends on the order that we teach this in. This will be negative 4x, this will be 7x, and then 7 times negative 4 does give me the negative 28. The base is negative 4, x minus 4, and the height is x plus 7. Now, if you wrote x plus 7, x minus 4, that is correct, okay? The order of your multiplication does not matter. All right, next one. Ooh, getting more fun. if that's the word we want to use. Now, this also does not have a greatest common factor, and I'm really not happy about that because I am not thrilled with the size of these numbers. But here's how I know there's no common factor. The 17 is prime, and it doesn't share, it's not a factor itself of either the 4 or the 15. So I know there's no GCF there. All right, let's just do this. Let's just go. Okay, so we have 4x squared and we have the negative 15. So what I'm not really happy about is that 4 times negative 15 gives me negative 60. And honestly, unless you're got a teacher that's really pushing the limits of awful, 60 is about like the yuckiest number. Now, it's not the biggest number. Like there are numbers bigger than 60 that you could work with, but are actually easier to factor. 60 has a ton of factors in it. So there's just lots of numbers that are factors of 60. So we got lots of pairs to find. We're going to keep an eye out for one that we can get a 17 out of. So we have 1 times 60, 2 times 30, 3 times 20, and I like that one for the 17, okay? If the 3 is positive and the 20 is negative, I think that's going to be what works. 3 times negative 20 is negative 60, and 3 plus negative 20 is negative 15. So I'm going to go ahead and stop that process right there because I found the combination of numbers that works. But if you didn't find it or you weren't sure, you would keep going. So you would do 4 times 15. We're sneezing. They're probably knocking dust down from the apartment above. Who knows? So we've got 4 times 15 and then 5 times 12, which would also give us the 17. Let's actually explore that. Okay, so we could keep going 4 times 15, and then we'd have the 5 times 12, and then 6 times 10, not 7, not 8, and then we're done. So this one can also give us a 17 if both the 5 and the 12 are negative. So this is another example of what I was talking about, where there's certain ones where you'll actually have more than one pair of numbers, so you don't want to jump at the first one. So negative 5 and negative 12 would also add up to give us negative 17. And I mentioned earlier in the video, only one of these will actually work. And that's why you've got to check both of the requirements. It's true that negative 5 plus negative 12 will add up to give you the negative 17, but negative 5 times negative 12, a negative times a negative, would give me a positive 60. And so it actually doesn't meet the second one. And it's why we do that double check. Okay, and just double check both of those things before we throw them into the area model. So we'll have 3x and negative 20x. I am not super thrilled with the 20 and the x. And now I'm going to go factor this way. Okay, so 4x squared plus 3x. 4 and 3 don't have anything in common, and my GCF there is just an x. And now I'm going to leverage that with the multiplication to do the rest. So I am intentionally not looking at that negative 20. 4x times x would give me the 4x squared. X times 3 would give me the 3x. And then again, I'm just not happy with this. I'm going to look at the 15 instead. 3 times what would give me negative 15? That would be negative 5. And now I'll check this. 4x times negative 5 gives me negative 20x. So all of those work. Everything adds up. And we've got our factors. Our base is 4x plus 3, and our height is x minus 5. Okay, so that was a good one to go over. And just to show you, just double check everything before you move forward. Doesn't happen too often, that particular thing where you'll have 2 sets of numbers that might work and you've got to test both of them. It's not very common, but it does come up, obviously. All right, next one. So this one also has no greatest common factor, and I know that because the 13 is prime, and the one underneath it also no GCF because the 11 is prime. So we don't have any common factors yet. So let's go ahead and just start working through these. So we're going to put the 6x squared in the upper left and the 6 in the lower right. And then we'll do our 6 times 6, which is 36. And we're going to be looking for two factors of 36 that add up to 13. And if you know them right off the bat, so I'll always have some students that just in their heads, they had an elementary school teacher that made them learn their times tables. And so they'll start running through those factors of 36 really fast, and they'll very quickly say it's 9 and 4. And they would be correct. So if you can do that without doing the scratch work of finding the factors, that is 100% okay. So we have 1 times 36, that doesn't give us a 13. We have 2 times 18, that also does not give us a 13. We've got 3 times 12, also not giving us a 13. 4 times 9, ding, ding, ding. We have our winner. That's the one that adds up to 13. 5 doesn't work. And then the only other pair is 6 times 6, which would give us like a 12 or a 0, but not a 13. So, and we would want a positive 4 and a positive 9. Do that quick check. 4 times 9 is 36 positive, and 4 plus 9 is 13. So we'll have 4x and 9x. Now this one is messier for finding a GCF, okay? It's just messier because you'll notice that we do have other kinds of common factors. So 6 and 4 share a factor of 2, 6 and 9 share a factor of 3. So you might want to go for maybe like this here where you're not tangling with the x's as much. It's your call. 4x plus 6, those are both even numbers, so they share a common factor of 2, and then you can work from there. So 2 times what would give you 6? Well, that would be 2 times 3. And then you might do, okay, 3 times what would give me 9x? That would be 3x. And then 3x times what would give me 6x squared, or 2 times what gives me 4x. Either way, it's a 2x. Now that's messier. So before I lock my answer in, let's double check each of these boxes and make sure that they work. So 2x times 3x, 2 times 3 is 6, x times x is x squared, so 6x squared. 2 times 2x is 4x, 3x times 3 is 9x, and 3 times 2 is 6. So I'm happy with that. So we have a base of 3x plus 2 and a height of 2x plus 3. All right. 2x squared minus 11x plus 12. No GCF. Okay, we already established that. So we're going to throw in our 2x squared and our 12. And over here, 2 times 12 is 24. And we want two factors of 24 that add up to negative 11. And again, if you know those factors of 24 and you're kind of rattling them off, you're like 3 and 8. 3 and 8. Those are the, yes, it's negative 3 and negative 8. And you are more than welcome to just go like, okay, negative 3 and negative 8. Okay, if you're not that fast, then you got to break it down into the factors. So 1 times 24 can't get an 11. 2 times 12, I can get a 10 and a 14, but not an 11. 3 times 8, there's our 11. 4 times 6, now that's another way to get a 10. So if I had a 10 there, I would want to double check that. And I think that's it. So 3 and 8, and they need to add up to negative 11. So they would both need to be negative. And before you dump them in there, double check. Negative 3 times negative 8 is positive 24. Negative 3 plus negative 8 is negative 11. Looking for a GCF, I am going to go this direction because 2 and 3 do not share a common factor. And so I only need to look at the x squared and x. So my GCF there is x, and I can do the rest of this with multiplication. 2x times 2x gives me 2x squared. X times negative 3 would give me negative 3x. And negative 3 times negative 4 would give me a positive 12. And I'm going to check on this one. 2x times negative 4 is negative 8x. So my factors are a base times a height, 2x minus 3 and x minus 4. I know this video is getting long, but for a lot of you, like we need to go through the explanation for all of this. Okay, finally, we have a common factor. So we have a couple common factors, and just looking at this, I see even numbers. And so that even number means that I will have a GCF of 2, and we want to get that 2 out first. So 2 times what gives me 2x squared? Well, that would be x squared. 2 times what would give me that 12? That would be a 6. So 6x, and 2 times what would give me 10? That would be a 5. So we want to remember that we have that factor of 2 out there. Setting up my area model. Now this is so much nicer because now I have to just deal with the x squared and the 5 instead of a 2x squared and a 10, which I have a 20 in play, and none of us wanted that. Multiplying 1 times 5 is just 5, and 5 is prime, which means I only have factors of 1 and 5, and fortunately, those actually do add up to 6. So 1 times 5 is 5, and 1 plus 5 is 6. So I can put in a 1x and a 5x, and GCF factoring, greatest common factor, going in either of those directions is an x. And this would be 1 times x, and this would be 5 times x, and 5 times 1 is 5. So we have a base of x plus 1, a height of x plus 5, but don't forget we have a common factor of 2 that we got at the beginning. So a lot of times students will drop that 2 out. Now, if you went ahead and factored that and you did not catch the plus or the times 2, at the beginning, here's what you likely might be staring at, okay? You are probably staring at 2x plus 2 times x plus 5, or you got x plus 1 times 2x plus 10, okay? And what that means is that common factor is still sitting in one of those parentheses, and you don't have to redo the problem, okay? Do not redo the problem. You can factor out that GCF at the end. So if you notice right here, you've got a common factor of 2, you can go and yank that 2 out. Okay, so you're left with 2x plus 1, and then or you can do it over here. It depends on where like you ended up putting it. So this you could factor out the 2, so you'd be left with 2x plus 5, and then you can move that 2 over to the front. So if you miss the common factor at the beginning, you made the problem a whole lot harder because you were dealing with bigger numbers than you wanted to deal with, but you don't have to undo your work. You can go ahead and just grab that common factor at the end. All right, next one also has all even numbers. So I know that I at least have a common factor of 2. You might want to double check and see if you've got a common factor of 4 or 6 or something bigger than that. But I don't think we do. I think we just have the common factor of 2. So I'm going to go ahead and get that out. 2 times 2 would give me the 4. 2 times 7 would give me that 14. And 2 times 3 would give me the 6. Setting up my area model. Here we go. And now I'm going to deal with the 2x and the 3. So 2x squared and the 3. And over here, 2 times 3 is 6, and we want 2 factors of 6 that will add up to a negative 7. So my candidates would be 1 times 6 and 2 times 3. This is the group that will add up to a 7, add or subtract. It just depends on whether you have same sign or opposite sign. To get the negative 7, they would both need to be negative, and we're just going to double check that. Negative 1 times negative 6 is positive 6. Negative 1 plus negative 6 is negative 7. So we'll have negative 1x and negative 6x, and then I'm going to GCF factor this way. X, 2 and 1, don't have anything in common. X squared and x, the greatest common factor is x. X times 2x will give me the 2x squared. X times negative 1 would give me the negative 1x. And what do we have here? Negative 3. So negative 3 times negative 1 would give me the positive 3, and 2x times negative 3 gives me the negative 6x. So my base is 2x minus 1. My height is x minus 3. And don't forget that GCF. Okay, same deal. If you did not get the GCF at the beginning, you should be able to look at the factors that you have at the end, and you should see that GCF still in there. And if you did that twice, please make a note to yourself, like, please look for the GCF first, because the numbers are much, much easier than if you missed that GCF. And this honestly, for Algebra 1 and even for a lot of Algebra 2, this is about the hardest version that you could find. So something with a GCF that also has a leading coefficient even after you take out the GCF. The only thing that might make that messier is if you didn't have like a prime number, but honestly, that's not an issue with the area model. That'll be an issue with some of the other strategies for factoring. So area model, that's not a complicating thing. Okay, almost done. I know this video is getting long. I apologize, but I want to be thorough in this. So we have another GCF right here. I can tell that they are all even. So I at least have a 2. So we could look for a 4, and we actually do have a 4. So 4 times 3 would give me the 12, and 4 times 4 would give me the 16. So we're going to grab the 4. Which is nice because that's going to bring this down to just an x squared, which I like better. 4 times 3 would give me that 12, and 4 times 4 would give me that 16. Setting up my area model. So we're going to have the x squared and the negative 4, much nicer. 4 times negative 4, 1 times negative 4 is negative 4. And my factors of 4 are 1 and 4 and 2 and 2. And we are looking for the pair that's going to add up to negative 3, which means I'm going to have to use the 1 and the 4. And I would need the 1 to be positive and the 4 to be negative. Before I dump those in there, let's double check. 1 times negative 4 gives me negative 4. 1 plus negative 4 gives me negative 3. And so we'll have 1x and negative 4x. GCF right here between x squared and 1x is just an x. X times x gives me x squared, x times 1 gives me 1x, x times negative 4 gives me negative 4x, and checking negative 4 times 1 is negative 4. So my base is x plus 1, my height was x minus 4, and we have the GCF. Bring that down. All right, 10 on the home stretch here. I do see a bigger common factor here. So just to kind of look at this, this one has a common factor of 2, okay, because they're all even, but they also share the x. You'll notice that this brought us up to x cubed, and so there's a common factor of x. So I have an x cubed, an x squared, and an x. So my GCF is actually 2x. So 2, this would be a 1, so that's fine. X times x squared would give me the x cubed. 2 times 6 would give me the 12, and x times x would give me the x squared. And 2 times 9 would give me the 18, and the x would be in there. So just quick double check. 2x times x squared is 2x to the third. 2x times 6x is 12x squared, and 2x times 9 is 18x. Setting up my area model. This one's not going to be too bad. So x squared, and then we have the 9, and we're going to do 1 times 9, which is 9, and we're looking for 2 factors of 9 that add up to 6. So our candidates are 1 times 9 and 3 times 3. There it is. Okay, so just to double check, 3 times 3 is 9, and 3 plus 3 is 6. So I am sure I've got that. Factoring this GCF, you can factor it either way. Okay, it's nice when you don't have a number in front of the x squared because it's pretty much going to be x and x. If you do have a number, you got to make sure you get it in the right spot when you do the factoring. 3 times x is 3x, 3 times x is 3x, and 3 times 3 is 9. So we have x plus 3 times x plus 3, and that GCF, don't forget the GCF, is the 2x. The other way you could write that is you could do 2x, and then you could say x plus 3 all squared, okay, meaning you have the same factor used in there twice. Last problem, I actually added this one at the end, so you're probably loving that because it made the video extra long, but I wanted to review the difference of squares. So this one does have a common factor, and that common factor is a 5. So 5 times x squared would give me the 5x squared, and 5 times 10 gives me the 50. And I wanted this to be a difference of squares, and obviously I wanted a 5 in there, and so I would have a 25, never mind. So this one doesn't factor any further, but I guess that's a good example in and of itself. I'm not redoing 30 minutes of problems. That's actually the end, and it's a good example anyway, because I intended for it to factor further, and obviously when I add a problem at the end at the last minute, that's, you're asking for trouble as a teacher writing stuff at the last minute. And that's actually it, because you cannot factor the x squared minus 10 any further. And a lot of times students will look at that and they'll say, oh, I should be able to factor this more. And they'll end up doing like x plus 5, x minus 5, or something like that. To try to make it factor further, and they don't miss it, they don't get it. But what I intended to have happen was something like this, where you might have 2x squared minus 50, that will work. And you factor the 2 out, and you're left with the difference of squares. Okay, and so you're left with that difference of squares, and that always comes from conjugates. And so that would be the x plus 5 and the x minus 5. If you want to go back and watch the video on special cases, I do address that in the video and in the practice set. So I apologize for me being like, oh, I'll just throw in an extra problem. That's why there's 11 and not 10. And then, just don't get the problem that I intended to have. But there you go. Okay. So that's that. It was a long video. I am aware of that, but again, critical skill and critical that you get the explanation in the work. So give this video a thumbs up if you found it helpful, if you hung with me all the way to the end. Subscribe to the channel for more math help. Comment to engage. Please ask some questions. This is a hardcore kind of strategy issue, lots of different ways to do it and think about it. And check out the other factoring videos. I will make sure that I link some other resources in the description box so that you can compare and contrast, look at algebra tiles, and so forth. Thank you for hanging with me till the end, and I will see you in the next video.